All right, well, I'm sorry I wasn't able to make it into class today, but I didn't want you guys to fall behind. So what I'm doing is I'm making 2 videos of the next few pages of the packet, and just follow along and keep notes. If you get stuck on anything, feel free to rewind and watch it as many times as you need to. Okay, number 14 says the following function can be modeled by the equation y equals a sine of bx plus d. And they want us to determine the values of a, b, and d and explain how we arrived at our values. Okay, so before we start, let's just keep in mind that a represents the amplitude. The b, whatever's in front of our x, represents the frequency. And then this d, when you have a number added to the end of your equation here, it means we have a vertical shift, which is also known as displacement. Okay, so I like to first start off by finding the vertical shift. Now, if you take a look at this graph here, what you'll notice is that this is a sine curve, like they say in the equation up here. And instead of the sine curve starting at 0, 0, where it normally would start right here, it was shifted up 1, 2 units. So the vertical shift is really going to be where you can draw the midline of your graph. Since this midline is right here, which is 2 units up, we can say that our vertical shift is at positive 2. So the vertical shift is at positive 2. Okay, we shifted 2 units up to start. All right, so I'm going to put that the d is our vertical shift. That's going to be at positive 2. I'm just going to box off our answers here. Okay, so now we need to go and find the a and the b. Well, the a is the amplitude, and the amplitude doesn't mean the maximum. You wouldn't say, oh, the amplitude's 3 because the graph reaches a height of 3. The amplitude is the height from the vertical mean. So basically, to get from the vertical mean to the maximum, you're going up 1 unit. Okay, so the amplitude is really from here to here. So you could just say, the amplitude is the maximum minus the vertical shift. So 3 minus 2. So your amplitude would be 1. And just to keep in mind, it's also the difference between the midline and the minimum of your graph. So 2 minus 1 also gives you that amplitude of 1. All right, and then finally, the b is your frequency. Now, the frequency is the number of complete curves between 0 and 2 pi. Now, if we look at this graph, we're just going from 0 to pi. So we're fitting one complete sine curve between 0 and pi. So if we wanted to figure out how many we would fit between 0 and 2 pi, well, if we were to reach 2 pi, let's say, which would be somewhere like all the way over here on the x-axis, you would fit an entire another curve. So the frequency would be 1, 2, because you're fitting 2 curves. So I'm just going to write the frequency. We're fitting 2 complete curves between 0 and 2 pi. So our frequency is 2. Okay, number 15 is similar to number 14. It again gives us a function that can be modeled by this equation here, and this time they want us to determine the values of a, b, and c. Now at this point, if you could just pause the video and try to do this one on your own, and then once you do it, you can hit play and see how you did. Okay, now with this example, even though they're using a different variable over here, it's still a number that's being added to the end of the equation. So the c still does represent our vertical shift. So it represents the same thing that the d represented in number 14. The b is our frequency, and the a is your amplitude. Okay, so again, I first like to find the vertical shift. So I want to figure out how far up was our graph shifted, or how far down was our graph shifted, from where your basic sine curve starts. Well, the basic sine curve starts at 0, 0. So you could see here, this is starting at 0, 1. It was shifted 1 unit up. So because our midline is at y equals 1, what it means is that our vertical shift is at 1. Okay, we started 1 unit up. So I guess down here again I'll write A, B, and this time C. And we first found the C. We found that to be positive 1. Okay, so now, next thing I like to find is the amplitude. So we know the amplitude is the difference between the maximum and the vertical shift, or between the vertical shift and the minimum. So the difference between the maximum, which is 2, and the vertical shift, which is 1, would be 1 unit, because 2 minus 1 is 1. So we look at the difference from the maximum to the vertical shift, or from the vertical shift to the minimum. Okay, now the frequency, again, is the number of complete curves between 0 and 2 pi. Well, here's 0, and here's 2 pi. We're really just fitting between 0 and 2 pi the first half of the sine curve. So the frequency is going to be 1/2, because we're only fitting half a cycle between 0 and 2 pi. Okay, number 16, we're going to skip that one. We're not going to have time to do every single one, so 16 is one that we're going to skip. So you could flip to number 17. Okay, so number 17 you really have to read to determine what's going on here. It says, a student attaches one end of a rope to a wall at a fixed point 3 feet above the ground, as shown in the accompanying diagram, and moves the other end of the rope up and down, producing a wave described by the equation y equals a sine of bx plus c. Okay, so before we go any further, basically what's happening is this guy's holding the rope 3 feet above the ground, and the rope is making the shape of a sine curve as he, moves this end up and down. It kind of, the rope goes up and down like a sine curve would. Okay, it says the range of the rope's height above the ground is between 1 and 5 feet. So I'm going to just kind of draw this on here. I'm just going to kind of sketch a little curve. So if we make a sine curve, what he's saying is that this maximum point up here is at a height of 5, and this minimum point down here would be at a height of 1. So it's fluctuating between 1 and 5 feet. Now it says the period of the wave is 4 pi. So remember, period is the horizontal length of one complete cycle. So since this is one complete sine curve, they're saying the period is 4 pi. So I can make this 0 and this 4 pi. So 2 pi would be, basically right here, right in the middle. Okay, so they want us to write the equation that represents this. So the A is our amplitude again, same thing. The B is the frequency. And the C, again, is your vertical shift. Okay, so we're going to start off with the vertical shift. So I'm just going to put this, actually this time they don't say label A, B, and C. I'm sorry, they don't say determine A, B, and C. They say to write the actual equation. So I'm going to first, off to the side, we'll write our A, B, and C, and then once we have those, we'll plug them into the equation. Okay, so the vertical shift, the C. Well, the C is going to be this midline right here, which is at 3, because 3 is the middle of 5 and 1. It's halfway between 5 and 1. So this right here is going to be our midline, or our vertical shift. Okay, so that's going to be at 3. All right, so our C is 3. Now the amplitude is the difference from the maximum to the vertical shift. So this would be our amplitude. It would be 5 minus 3, which is 2. And same thing here. From the midline to the minimum would be 3 minus 1, which is also 2. So our amplitude is going to be 2. All right, and then the frequency is the number of complete curves between 0 and 2 pi. So you could see that if from 0 to 4 pi is a complete curve, then from 0 to 2 pi we're only fitting half of the curve. So here, your frequency is really just half. You're fitting half of a curve. So the frequency is 1/2. Okay, so now they want you to actually take it and substitute these numbers back into our equation. So I'm going to bring down the y equals. I'm going to replace the a with a 2. Bring down the sign. I'll replace the b with a 1/2. And bring down the x. I like to put that in parentheses. And then plus 3. So there's our equation. All right, number 18 says the times of average monthly sunrise as shown in the accompanying diagram over the course of a 12-month interval can be modeled by this equation right here. And they want us to determine the values of A, B, and D and explain how we arrived at our values. Okay, so what you'll notice here is this graph, instead of the x-axis being numbered in terms of pi, like the other examples, it actually has numbers, which makes sense for the problem because it's showing the average monthly sunrise over a 12-month period. So the x-axis is representing your month. Okay, so we're again going to have to find the amplitude, frequency, and vertical shift. So we'll start off with the vertical shift like we've been doing. I'm just going to label on the bottom here A, B, and D. Now, the vertical shift is really just the midpoint of your maximum and your minimum. So if you look here, our maximum is right here, which is at a height of 8, and our minimum is right here, which is at a height of 5. So if you want to find the midpoint between 8 and 5, I mean, you could do it one of two ways. You could say, all right, if I start at 8, if I count down 1, that brings me to 7. So from the 5, I'd have to count up 1, which brings me to the 6. And then halfway between 6 and 7 would be at 6.5. So you can kind of count your way in and do it like that and say, all right, so my vertical shift, or my midline, I'm just going to write VS, is at 6.5. Now, if you want to do that algebraically, I mean, if you want to find the middle of two numbers, all you really have to do is just add up those two numbers and divide by 2. So if you wanted to find, the average of two numbers or the middle of two numbers, you would just add them up. So we would take our maximum, which is 8, and our minimum, which is 5, and we would just average them, add them up, and divide by 2. So 8 plus 5 is 13, and 13 divided by 2 is 6.5. Okay, so either way, whether you do it algebraically or whether you kind of just look at the graph and count your way in, you'll get the vertical shift to be 6.5. Okay, now from here, we could find the A, the amplitude. The amplitude is really just the distance between the maximum, which is 8, and the vertical shift, which is 6.5. So if you want to find the difference between 8 and 6.5, just subtract them. So 8 minus 6.5 is 1.5. Okay, so that is going to be our amplitude. Now the frequency on this is a little different because since the we know frequency to be the number of complete cycles between 0 and 2 pi, but we're not labeling this in terms of pi. So we have to go about it a little bit different. Whenever the x-axis is labeled using numbers instead of pi, what you're going to do is you're going to go back to that formula we learned when we first started the packet. Period equals 2 pi over the frequency. Now we could tell the period by looking at the curve because period is just the horizontal length of one complete cycle. So since this is a cosine curve here, they actually don't show you this, but if this curve were to continue on, because we're talking about a 12-month period, what would happen is this would actually come back up to reach a maximum of 8, kind of like it did over here. So what you could see is the period, the horizontal length of one complete cycle would be 12 units, right? We're going from here to here. It's going to be 12 units. So since the period is 12, in this formula right here, I'm going to replace the word period with 12. And then I'm just going to bring over, instead of writing 2 pi over frequency, the frequency is what we're looking for. I'm just going to call that an x. Okay, so all we're going to do is just solve this equation for x. So since the right-hand side of the equation is a fraction, let's make the left into a fraction by putting it over 1 and just cross multiply. 12 times x is 12x. And then 2 pi times 1 is just 2 pi. And to get the x by itself, divide both sides by 12. And since 2 over 12 simplifies to 1 over 6, you're going to have 1 pi over 6, which is just pi over 6. So that is our frequency. So there you go.